This lab video is a debriefing for the full lab data collection. In this video, we'll look at anchoring and adjustment in decision making, then consider how anchoring affects our shopping decisions, focusing in on our study, and how I'll analyze our results. Anchoring in decision making was part of the research program of Debriefing and Kahneman. We'll look at Kahneman and Debriefing in quite a bit of detail when we look at decision making later in the course. I've included a 1974 article they wrote in Science to get you started. You'll find that there's actually quite a bit in that paper that you don't need for this lab. You should probably, for now, focus on the section on anchoring. Later, when we consider decision making as a topic in the course, you may want to come back to this paper and give it a read. It describes a lot of the heuristics that we'll be looking at in that module. So in Kahneman-Tversky's original study, they had participants estimating various quantities. For example, in one condition, they had participants try to estimate what percentage of African countries they thought would be in the UN. Now, to do this, what they would do is start by spinning a rigged wheel of fortune that supposedly could come up with a number anywhere between 0 and 100. But in fact, they had rigged it so that it either came up in a 10 or a 65. What they were asked to do was to say whether or not they thought the answer to the question was greater or less than their spin. So for example, if I was asked what the percentage of African countries were in the UN, and then I roll a 10, I have to say whether or not I think that percentage is greater than or less than 10. After making that estimate, participants were asked to say what their answer was. Now, the interesting result here was that if participants spun a 10, they usually guessed that the answer was greater than their spin, and they gave an average estimate of 25. People who spun a 65 generally felt that the actual percentage was less than that, and their estimate was 45. You'll notice there's quite a big difference between these two estimates. One group estimating that they believe the percentage of African countries in the UN is 25%, and then another group that estimates it to be 45%. And the only difference between the two groups is the result of that initial spin of the wheel. The way Kahneman and Tversky explain this effect is that they say you first start by forming an anchor for your estimate. So by asking you to spin the wheel and then say whether or not you think the answer is greater than or less than the number you spun, you then choose that number as an anchor for estimating your answer. The second part of this anchoring process is adjustment. So in this adjustment step, what participants do is then say, okay, I've got an anchor, it's 10, I think it's bigger than 10, and then they make an adjustment and guess a number that's bigger than 10. And then the group that spins the 65 does essentially the same thing. They start with an anchor of 65, they believe the actual answer is less than that, so they adjust that 65 down to 45. And what happens in both these cases is the adjustment is not large enough. So what does this have to do with marketing decisions? I included a second paper to go with this full lab report by Wansink and colleagues. They did 2 field studies. These would be studies that were actually done in grocery stores, and then 1 lab study that looked at purchasing decisions. And they used 2 different types of anchors. In one anchor, they gave multiple unit prices. So you'll recall that when you participated in our data collection, we had some items that were listed as 5 for some price. And the second type of anchor was quantity limits. So again, thinking back to the experiment, some of the items had a quantity limit where you couldn't buy more than 5. Now what's interesting is that in both of these conditions, participant bought more products when they had one of these 2 anchors, either a multiple unit price or quantity limit. This is kind of interesting too. I don't know if you've ever thought about quantity limits. Our usual reaction to see something on sale with a quantity limit is to think, oh, they must be losing money and they don't want to sell too many of them. But in actual fact, what this research from PSYC tells us is that grocery stores can use this as a way to get people to buy more of those items. So in our study, what I did was I had you participate in one of two different versions of the experiment, which creates two groups, although we're not going to make any comparison between the groups. Each group is a control for the other group. So the group one were students whose last name started with a letter between A and MC. The second group, students whose last name started with ME to Z. And we were looking for the purchasing effects for the same two types of anchors that we saw in the PSYC experiment. So we had some quantity for a fixed amount. I used 5 for some value. And then we had a limit on quantity. The limit was 5, so a limit of 5 per customer. So what I did was I used each group to serve as a control for the other group. Say you were in group 1 and you had 5 bottles of Coke for $3.75. Then the other group had Coke at 75 cents a bottle. If you were in group 2 and you had Mr. Noodles 5 for $1, then group 1 had Mr. Noodles for 20 cents each. So the price is the same. It's just that one group has the control, no limit on quantity, or no multiple items for a fixed amount. So each group served as a control for the other group. If you want to see this, you can go through the PDFs we've posted on Moodle and just compare the conditions, and you'll see that wherever you see a limit on quantity in one group, you'll find the limit has been lifted on the other group, but the price has stayed the same. I also introduced a novel condition in here, and this is based on a real-life experience I had at the Atlantic Superstore in Antigonish one day. I don't know how well you can read this sale price. You can probably see the 2 for $5, but if you read the fine print underneath, it actually says, or $2.29 each. Do a little math for you. If they cost $2.29 individually, then 2 of them will cost $4.58. That's 42 cents cheaper than buying 2 of them as a unit. I originally thought this must have been a typo. I took a picture, I took it to the customer service desk and asked if they realized they were doing this, that it was actually more expensive to buy 2 than it would be to buy them individually. And the person there didn't seem to be particularly fazed by it. And to be honest, I didn't actually check to see what they would charge me for 2, if they charged me the $5 or the $4.58. But I thought it would be interesting to find out if we would be duped into buying more, even though it was more expensive to buy more. So the question we're looking at here is simply, will you buy multiple items even if it's more expensive to do so? For the results, I'm going to present you with 3 different t-tests. Remember that t-tests tell us if our differences are happening because of our experimental manipulations or if they're just good luck. So first, for this multiple item ripoff, what I'm going to do is what's called a one sample t-test, just looking at the overall purchases made. So we'll count up and find out what the average number of items bought in these 2 conditions were, and then I want to see if that number is significantly greater than 1. Ideally, what you'd want to do in this situation is buy either none or just 1. That's the cheapest thing to do. Personally, I didn't buy any of them because I wasn't sure what was going to happen if I bought more than 1. So what we'll do is we'll do a test to see if people buy significantly more than 1. If they buy significantly more than 1, what it's telling us is that they may be duped into buying multiple items even though they're more expensive to do so. So that's the hypothesis we'll test here. Did participants buy significantly more than 1 item in the multiple item ripoff condition? Then we'll want to look at the 2 anchoring conditions, and we'll do 2 dependent t-tests here. Just to remind you, there are 2 different types of t-tests that can compare 2 means. One of those t-tests looks at 2 means that come from 2 groups. That was the example we saw earlier with my miracle memory pill. We had a placebo group and we had an experimental group, and they were different groups of people. In this experiment, don't get confused by the fact that I had you run in one of two versions. We're only looking at one group of responses. The two groups that ran were simply control conditions for each other. So when I tally up all the 5-4s in one condition and compare those with the single item prices, I'll be doing a dependent t-test because you did both 5-4s and control conditions in your version. So we're looking at responses from the same people. First, starting with the quantity, the 5-4 condition as I like to call it, versus a single price control condition. That will be one t-test. We'll see if people buy significantly more when they're labeled as 5-4 instead of just a single item price. And we'll be doing a dependent t-test to do that. And then I'll do a second dependent t-test looking at the limits when we have a limit of 5 versus a single item price with no limit. And again, we'll do a dependent t-test to see if people buy more in the limit condition. I've got a couple starting references for you. The Tversky and Kahneman article in Science is posted, and we have the Wasink et al. Article also posted. In addition to these two articles, you should find 3 or 4 other articles that you can reference in your introduction and in your discussion to flush out a nice full reference section. There is a grading rubric that has been posted on Moodle, so you can see how we'll be grading the various sections of this full APA report.